Welcome to Yong Tuition. Let's talk about the matter wave today. In 1924, the French physicist de Broglie proposed that a particle can be described by a kind of the wave, by an energy of the study of the light, in which both the wave model, namely the electromagnetic wave, and the particle model, namely the photon, have been applied to start the electromagnetic radiation. So the idea is very important in the history of development of quantum mechanics. Actually, later on, it was experimentally verified by discovering the electron diffraction, and in which that electron does behave like the wave. In addition, if you look backward, and you may find that the Bohr's atomic theory or Bohr's atomic model can be explained by using the wave idea, namely the standing wave. Of course, more importantly, in less than 1 year, Schrödinger developed or discovered the wave equation known as Schrödinger equation. So you can see that the matter wave proposed by de Broglie played a very important role in the development of quantum mechanics. However, if you look at all the textbooks, you can hardly find the discussing of the speed of matter wave. Yeah. In many cases, we just mentioned the wavelength of matter wave. So in this short talk, I'm going to demonstrate that the speed of matter wave actually is different from the speed of particle. Let's consider a particle with mass m moving with constant speed in space, and hence the momentum p will equal to mass multiply velocity. From this simple formula, we can obtain the velocity of the particle can be written as p divided by mass. In addition, the total energy of this particle, which is just its kinetic energy in this case, can be written as half mv squared. Or if we just use the first formula, we can obtain p squared over 2m. So these are two simple formulas obtained by using particle model. On the other hand, if we describe this particle as a wave, and we will get different description. In this case, the wavelength is the peak-to-peak distance is called wavelength. We use a lambda. Okay. So according to de Broglie, the wavelength is related to the momentum. So the p is equal to h divided by lambda, where h is a Planck constant. Talking about the Planck, here we have to use Planck's formula too. That is, the energy of the particle can be written as a constant h multiply the frequency of the wave. So they are basic equation we are going to use to derive the speed of the matter wave. Okay. First, from the equation 4, we can obtain that the frequency can be written as E divided by H. Okay. If we substitute the equation 2, then we can have 2mh multiply p squared. Okay. So we just replace the E by the p squared divided by 2m. This is h. Then we substitute equation 3 to replace the p. We got m h. That would be h over lambda square. Now we can cancel 1h. We obtained 2m. That is h over lambda square. If we just multiply lambda on both sides, we got lambda multiply frequency will equal to that 1 over 2m multiply h over lambda. Okay, so h over lambda again represent the momentum according to de Broglie. So in this way, we can obtain 1 over 2 p divided by, it's just equal to p divided by m. According to equation 1, and this is exactly the v over 2, where v is the velocity of this particle. Okay. Now, in order to determine the wave speed, so the wave also travel at a certain speed, can we use Vd to denote the de Broglie's matter wave? According to the wave theory, the wave speed, so that's wave speed, can be written as the product of the lambda and f. So by comparing with these two results, we got this very strange result. Namely, the speed of matter wave is exactly half of the speed of particle associated with this matter wave. So what does that mean? Which means that there are some discrepancy in using de Broglie's wave model. If the wave is associated with a particle, naturally we would expect that the speed of particle would be the same as the speed of the matter wave. But these results show different. So some people argue that perhaps we can use more sophisticated wave in order to obtain that, in order to make sure that these two speeds are the same. But I leave this question to you and just draw your attention that the speed of matter wave in this case is different from the speed of particle. Thank you for watching. Have a nice day. Goodbye.